Okay, so this is the second video for homework number 3. So since I've described the situation, now we're going to figure out how to code it. So the first thing I'm gonna do is paste something into here. So this is basically giving us a path to our GitHub website, and it's letting us get all of the information from it. So we'll hit Shift Enter. Take a little bit to load. That's good. So now we're going to import some stuff that we need. So we're going to need .map. And then we're also going to do from tools.tree, this thing, import VSC comp and range. And then we're going to also do import tools.che as che. And we're going to do Shift Enter. Invalid. Oh, I need a comma there. I'm going to turn off my notifications. Let's see, Shift Enter, and that's good. So now what we're going to do, since I talked about it, so the R value is 8.314, and that is in joules per mole times Kelvin. So we're just going to set this up as a variable. We're just going to assign it a number so that we can use it in our equations after that. So now we're going to do p equals che dot props. So this is where we will put our different substances that we have. Nitrogen, I didn't spell that right. Nitrogen, there we go. And then we have oxygen. Then we have argon. And then we have water. So we're going to do that. Make sure that's good. Okay. And then now we are going to define our model. So here's our model. And we have C and R. So that's what we're going to be using to store all of our different variables and all of that. So first we have R dot PW equals P dot the pressure of the vapor form, C dot T, and we're going to put 3 in this. Then we're going to have R dot V vapor. So the so this part, PW, is the pressure of the water. PVAP is pressure of the vapor form. VVAP is volume of the vapor form. So we want it to be C dot V total minus C dot VW underscore I. And then we are going to have R dot N underscore WVAP, so water vapor, equals R dot P water times R dot volume of vapor form divided by R, which is this value, times the temperature. And then we're going to have R dot N of air. So this is for water vapor, this is for the air, equals C dot PI times R dot VVAP divided by R times C dot TI. So C dot TI is the initial temperature. And then finally we're going to have R dot P, pressure, equals R dot N, the moles of air, times R, times C dot T, the temperature, divided by R dot volume of the vapor form plus R dot pressure of the water. So this may look like a lot of different letters and it just kind of looks like a mess. So let's go over it. So the R dot PW is the pressure of the water. P dot PVAP, that is the pressure of the vapor, and C dot T is the temperature. So that's the same for VVAP, that's the volume of the vapor. V total is the total volume. VW is the underscore I is the initial volume of the water, but we're not losing that much to the vapor form, so it's not necessarily too bad. And then this is the moles of the water vapor. This is the moles of the air and all of that. So all of these R dot whatever, it just stands for a variable. So now we're gonna have that, I don't know how you would say that, but that in parentheses C dot PF. So we're trying to find so we have the final pressure and then R dot P. And then we'll have R underscore or N underscore W constra, we'll call it that. And then R dot N water vapor, C dot N water vapor underscore Z. And then what we'll want to do is we will return the P constra and the N underscore water constra. We'll shift enter, make sure we don't have any problems. That's good. And then what we want to do is we're going to do something C equals dot map. So we're going to assign some values. So we're going to say C dot W underscore total equals 1 point. So that stands, oh, we don't want that. So that stands for the 1 kilogram of water. We've got C dot P I, and that'll equal 1 times 10 to the 5th, which would be our initial pressure in pascals. So that's 100,000 pascals. And we'll do C dot PF, and that is going to be 2 times 10 to the 5th. And then we're going to have C dot TI, which is our initial temperature. We're going to have 298. Then we're going to have C dot N underscore water vapor underscore Z, and we're going to have 0.3. So that's how many moles of water vapor that we want. So now we're going to calculate the volume that we want. So C dot VW underscore I equals C dot W underscore total divided by P dot RHOL of C dot TI, and we want 3 there. Nope, we don't want that in quotes. We want just 3 there. And then we're going to have C dot T. We're going to make it into a range. So let's say 350. So, and then our low, let's go with 300. Our high, let's go with 400. And then we're also going to do the same thing for our total volume. We're going to make it into a range. So let's say 0.015 for that. Our low, let's put 0. Then our highest, let's put 0.03. So run that. Not necessarily sure what that means, but it's not giving me an error, so let's just keep going. So VSC, so that's what we did up here. We have the VSC up there, so we want VSC of C and model. And then we also want VSC.solve verbosity equals 0. So this is when we are taking the left side and the right side of the equation, and we're subtracting them, and we're finding the difference. Let's see. VSC dot solve. Verbosity equals 0. Let's see, what is it saying? Okay, let's see. VSC.VDF. Okay, so there's a problem here. Verbosity. Okay, I'm not really sure what the problem is, so I will be right back. Okay, so I've gone back over all of my code and I figured out what it was. I had some typos with the names of the variables. So once we go down, we find that the temperature is 365.7 kelvins, and then the total volume is 0.01289. So yeah, thank you.